If you go to safe load table for W and S shapes in the text for Unit 5, it talks about using tables to select beams for different lengths and uniform loads. There is a table at the bottom of this text that has been scanned from another textbook. You can definitely use this, but I find it to be a little difficult to read. So I'm going to show you how to use Excel to create our own that's a little more dynamic and, in my opinion, kind of fun to do. So we'll start with example 5 here, and I will show you how to modify the tables we have been using to quickly and easily pick out the right beam for the job. So the first thing I'm going to do is set up our calculator that's going to kind of add the dynamic aspects to our table. Using our example 5 here, we have let's see here, 40 kips on an 18-foot beam. All right, so we'll put in our 40,000 pounds, 18-foot beam, and then our allowable bending on this is still going to be that A36 steel, so that's 24,000 psi, and our elastic modulus of elasticity is still going to be 29 million. If you look back on case 2 on table 3.1 from unit 3, the moment is equal to our total load, or our big W, times our length, divided by 8, not 2, and then I'm going to convert this to inch pounds, not foot pounds, so I'm going to then take that times 12. And then our next step is finding our section modulus. So when we're going through our chart, we can easily pick out, well, in the previous stuff, how to pick out the right beam, but we're going to add a little more to this. So our section modulus was equal to our maximum moment divided by our allowable bending stress. And our deflection was, our allowable deflection is our length divided by 360. Yep. So we'll go length divided by 360, but that's going to give us in feet again, so we're going to do this in inches, so we'll multiply that by 12. And then to solve for our moment of inertia, we can actually manipulate our deflection equation to find the moment of inertia. So let me pull up, this. So our deflection equation is for the uniform load is going to be, our deflection equals 5, wow, that's real bad. 5, that's still bad. 5 times our big W, there we go, times our length cubed over 384 times our modulus of elasticity times the moment of inertia. So if we simply just swap these two, we can solve for our moment of inertia, because we've already calculated the allowable deflection. So let's put that into our Excel here. So that's going to be 5 times our big W times our length, but we're going to multiply that by 12 to convert it to inches. So times 12, and all of that would be cubed. Then that's going to be divided by parenthesis 384 times modulus of elasticity times now deflection, and close parenthesis. So there's our moment of inertia. So now our calculator is set up, and we can start applying some of this information into our table. I have some of this already set up. I need to get rid of some of this. This is something that I'll be getting to here in a second, the conditional formatting. So let's start filling in some of this stuff here. Our deflection is going to be, we're going to use, this is the actual deflection, not the allowable deflection. So just like we just solved for our moment of inertia, we'll use that same equation, just swapping the d for the I. So we're going to take, once again, same formula basically, 5 times our big W. So I'm going to click on this tab, click there, times, and I named all these, so that should, yeah, that's just going to be an L. But once again, we got to convert that to inches. You probably could add a new cell in here for a feet and inches, so it just does it automatically, so you're not having to do it every single time. And then that is divided by 384 times E times I. And press, oh wait, sorry, not that I. We need, we're going to take the moment of inertia from the table itself. So let's go back over here and click on this one. And press enter. I already have the formatting on there, so let me get rid of that. As you can see, anything in red is actually, if you're kind of paying attention, that's greater than the allowable deflection. So I'll show you how to do that in a second here. Clear from selected cells. Okay, so then the other thing we need is our allowable uniform loads, which in order to solve for what that would be, we're going to use a couple equations and kind of combine them. Let me erase this stuff. Okay. So we're trying to solve for our allowable load, so our big W. So we're going to use an equation that has that as one of the variables, which our maximum moment equation will do well for that. So that's M equals L, or W times L over 8. And we don't know our load and we don't know our maximum moment. I know that's in our calculator, but this is kind of like the maximum moment for each individual cross section. So we're going to need another equation that we have all of our knowns. We know our section modulus has our maximum moment in it in terms of its equation. So that section modulus equals maximum moment over our allowable bending stress. And then to kind of remanipulate that, we know that our maximum moment also equals our section modulus times our allowable bending stress, FB. Now we can kind of substitute things in here. So S times FB equals W times L over 8. Sorry, this stuff is kind of getting all jacked up here, but so moving things around, we know that big W equals S times FB times 8 over L equals W. And now we can put that into our table and have our allowable loads. So let's jump back over to Excel and let's put that in there. So we said that we're going to have our section modulus times our allowable bending times 8 divided by our length, which we're going to need to convert to inches, so that's length times 12. And press enter. And that auto-populated that for us. Let's do some formatting here. I should have these all in here when you have to do this yourself. Custom, scroll down to the bottom. This is going to be in pounds. Right there. That should do it. Total load, that's, I think I already said that, that's going to be for a little later here. I think everything else, I think this is all we need for right now. Let's start doing some conditional formatting. We want anything less than what we calculated for our section modulus to be in red, so we can quickly and easily see that those particular beams are not good. So let's select all of this and then come up to conditional formatting, and then we're going to highlight cell rules, and we're going to say anything less than, and then in this cell here I'm going to click this button and then click on our calculator. Anything less than this, press enter. We can leave this as just a light red fill-in, or you can even do a custom format if you want to make it look the way you want to, but we'll leave it with just that light red. So now it's highlighted each of the section moduluses that would not work for this particular length and load. Let's do the same thing for deflection. We'll select all of these and right click, and not right click, we'll come back over here. We want to highlight anything that is greater than our allowable deflection to be red. So once again, click there and there. We will click on our allowable deflection, press enter, and light red is fine. And let's scroll up again. And as you can see, it's highlighted anything that is greater than 0.6 in red. So now we know that those would not be a good choice. We're currently, right now, this 16 by 31 would actually work with what we have currently laid out. Now I'm going to move into calculating the weight of the beam and something like fireproofing, where they wrap the beam in concrete and then use those weights also in our equations to make sure that we're selecting the right beam for the job. So this WFP, that's the weight of the fireproofing around the beam. If we come over to our text here, so in example 5, they just kind of picked one a little greater, and that's kind of the reasoning behind that. We're going to actually go a step beyond example 5 and use this provision for beam weight. Figure 5.4 here shows the beam being encased in concrete, and the equation for calculating the weight of the concrete around the beam is right here. Let's see here. So that's just going to be our depth of the beam times your width of it, b, plus 3. And then, so let's put that into our Excel table here. So that's going to be equal to, let's scroll over, depth of the beam times, and in parentheses, our width of the flange plus 3. Press enter. I'm just calling this the MFP, so that's the maximum moment of the fireproofing and the beam. That's going to be our, let's see here. So before I go any farther, I'm going to quick change our calculator out to use the numbers in example 6 then instead of example 5. So that's going to be 16 feet for our length, and then 38 kips for our load. So our load is 38,000 pounds and 16 feet. Okay. So I already got this in here. So our equation, let's go back over here, to solve for our maximum moment is just like it always has been. We're using little w because this is pounds per little linear foot, so it's going to be a little w times our length squared divided by 8, which is what I put in there. And I'm doing the sum of the weight of the beam and then the weight of our fireproofing. Where did I put that? So as you can see there, I have the sum of the weight and the fireproofing times our length squared divided by 8, and then multiplying it by 12 to convert to inches. And then for our section modulus, your section modulus equals your maximum moment divided by your allowable bending stress. So that's what I did here. And as you can see, we're about the same number as what is in the text on a 14 by 30. 2.63, and it in the text it was calculated out at 2.66. So now the check here is we need to make sure that that number is less than the difference between the section modulus of that particular section, the 14 by 30, the difference between that section modulus and your calculated section modulus. So we had a section modulus of 41.9 for the 14 by 30, and we calculated our section modulus at 38. So the difference between those two is 3.9, and 3.9 is greater than 2.66. So we're good on that. So let's start adapting our table here to kind of match up for that stuff. All right, so we're going to format this column here to have any cell that has a greater value than the difference from the table value for your section modulus and the calculated section modulus. So let's select all these. I'm going to scroll back up, and we're going to go up to conditional formatting, and we're going to create a new rule. We'll click on use a formula to determine which cells to format. We're going to press equals. This column is K. We're going to keep that consistent or constant K. So $K, and then the row starts at 2. So 2. So we want to make sure that if it's greater than the difference, so greater than the difference between, greater than this, but we want that to be just the $N2 minus, not plus, minus our section modulus, and press OK. And nothing happened because I shouldn't have finished that. Let's go back to manage rules, and we didn't put any formatting, so that's why nothing happened. So let's edit that. We'll click here, and then I'm just going to make it red with my font being white. Hit OK, and apply. And now anything that has a greater value than that difference is red, so now we know don't select that one. Now that should be enough to make this functional, but to kind of just add a little more visual feedback to this, let's also add in a column for total load and format it so that to compare our total load and allowable. So our total load is just going to be our W plus this guy and this guy, but we need to change these over to pounds. So let's take these guys times our length, which is L, and press enter. Let's see, what did we get? Okay, now we can look at our 14 by 30. Our total load is less than our allowable, so that's good. So let's also do some formatting on this guy, similar to what we did with the section modulus there. We'll go conditional formatting, new rule, equals, let's see here, that is Q, so $Q2 is less than our $R2. Let's go formatting. Okay, wait, sorry, I did that. I always get that backwards. Well, I'm going to do this anyways. Red and white. We want anything that is greater than that to be in red. Anything that isn't, not to be formatted. So let's swap that over. Hit OK. There we go. Now you got even a little more information on what is the appropriate beam to select. There are a couple problems on here, so you'll get your calculator and your table set up here, and then when you get to the problems, you just have to pop your loads and your lengths from the, let's see, where's that at? Save loads and provision for beam weight. So pop these numbers into your calculator, record them on that tab, and it should be pretty easy once you get the table and your calculator set up. So obviously contact me via Slack, Zoom, or Geely, and let me know if you need help.